Hello dear friends, welcome to all of you on the playlist on the process calculation, and we are solving some problems on the process calculation. So the problem statement here is that how many grams of the barium chloride will be required to react with the 5 gram of the sodium sulfate. In the problem statement we are given with a balanced chemical equation, and we are asked if we have 5 gram of the sodium sulfate, that is one of the reactant, then how many mass of the other reactant will be required. So my dear friends, we know the concentration means mass of the one reactant, and using stoichiometric calculation we can easily calculate the mass of the barium chloride, that is the second reactant of the reaction. So let's perform our calculation. We are given the mass of the sodium sulfate and asked to calculate the mass of the barium chloride, which can react with the 5 gram of the sodium sulfate. So first, to perform our stoichiometric calculation, we need moles, and in the problem statement we are given the grams. So convert it into mole. We use the basic relation number of moles is equal to the mass or over molar mass. So we know that the molecular weight for the sodium sulfate is 142 gram per mole, and we have mass 5 grams, so we can easily calculate the number of the moles using the relation number of moles is equal to the mass over molar mass. So here we have number of moles equal to 5 divided by 142. So finally we came up with the answer number of moles equal to 0.0352 moles. So now we have the moles of the sodium sulfate. So performing our stoichiometric calculation, we can easily find the moles of the barium chloride, and then following the equation number of moles is equal to the mass over molar mass, we can get the mass. So let's perform this procedure. Now first we need to look up that what is the stoichiometric ratio of barium chloride to the sodium sulfate. As we can easily see from the equation that if we have 1 mole of the barium chloride, then we need only 1 mole of the sodium sulfate. So here we have the ratio, required stoichiometric ratio 1:1. So if we have 0.0352 moles of the sodium sulfate, then what would be barium chloride required? This one we call X, and performing our calculation further, we have 1 over X equal to 1 over 0.0352. Now using cross multiplication we get X equal to 0.352 moles.
We can also guess roughly from the figures that if we have 1 mole, then we need 1 mole of barium chloride, and if we have 0.0352 moles of the sodium sulfate, then ultimately we require the same amount, 0.0352 mole. So this was just a theoretical procedure. So X values comes out to be 0.0352 moles. This is the quantity in moles that is required for barium chloride. So now we have the moles and we are asked to calculate the mass. So we have moles of the barium chloride 0.0352, and we know that the molecular weight for the barium chloride is 208 gram per mole. So we have mass equal to the 0.0352 into 208. So finally we came up with the answer mass of the barium chloride equal to 7.3239 gram. That is the mass that we will require to if we have 5 gram of the sodium sulfate. So this was the answer, my dear friend. Here we have part B of the same question, and we are asked how many grams of the barium chloride are required for the precipitation of the 5 gram of the barium sulfate. Now note that we have now the quantity of the barium sulfate. This one here we can easily observe that this is the product. So now from a quantity that is product, we are asked to calculate the quantity that is reactant. So if we have 5 gram of the barium sulfate, what would be grams of the barium chloride that are required? So Here is the same procedure. This is given in the grams to us, and we need to convert it into the moles so that we can further continue with our stoichiometric calculation. So we know that the molecular weight of the barium sulfate is 233 gram per mole. If you don't know the molecular weight, don't worry, you can easily calculate by substituting the individual molecular weight in the formula. So using the relation number of moles is equal to the mass over molar mass, we have 5 divided by 233, and finally we came up with the moles of the barium sulfate 0.021459 mole. These are gram moles, my dear friend. So now we have the number of moles and we can further continue our calculations. So from the balanced chemical equation, we have to observe our desired stoichiometric ratio. We need to observe the stoichiometric ratio of the barium chloride to the barium sulfate, as these are the choices, my dear friend. So barium sulfate to the barium chloride ratio is 1:1 from the stoichiometrically balanced chemical equation. So if we have 0.021459 moles of the barium sulfate, then barium chloride is X, that is unknown to us. So for moving on to our calculation, we have 1 over X equal to 1 over 0.021459. So using cross multiplication, we get X values to be 0.021459 mole, and these are also gram moles, my dear friend. So now we have the number of moles of the barium chloride, and the next step is to calculate the grams from the moles. So we have to use the same relation, number of moles equal to mass over molar mass, and here we get M equal to the number of moles multiplied by molecular weight. So we have number of moles, and we also know that the molecular weight for the barium chloride is 208 gram per mole. So from the above relations, putting these values in the above relation, we get mass of the barium chloride to be 4.463 gram. So this is the mass of the barium chloride that would be required if we want 5 gram of the precipitation of the barium sulfate. So this is the answer, my dear friend.
Till now, we have solved 3 basic parts of that problem, and the procedure that we will follow in the solution of the next part would be same as we have discussed earlier. So the drive links for the answer has been provided in this description. Just follow that links and get the answer. Thank you so much for watching. Follow us on YouTube for more videos.